All right, so what number was it? This was 4 from the homework. Okay. The first thing, obviously, you want to look for is, can you factor something out? There's nothing that goes in all 3 terms. So then the second thing I would say, okay, there's 3 terms. And if there's 3 terms, this is either going to be a perfect square trinomial, or it's going to be the ones where we find the factors the last, the sum to the middle, or multiply the first times last. So from those 3, if you notice the one at the front and the one in the end, they are both perfect squares. So then the next thing I would do is test for my perfect square trinomial. So I would square root 25z squared, and I get 5z. I would square root the 9, and I would get 3. Multiply those together, I get 15z, and then double that product, and I get 30z. If that matches your middle term, ignoring the sign, then this passes my perfect square trinomial test. And then I factor it. I square root the first term, I square root the last term, I take the sign from the middle, I put it in the parentheses, and square it. You would get the same answer if you do the first times last. You're just dealing with much larger numbers. That's all. You're welcome. Other questions from the homework? No.
In parentheses, x squared plus 8, and then the parentheses ends, and then squared, minus 36x squared.
Like that?
Yeah.
Okay. So this is actually different 2 squares. Like those are 2 perfect squares, right? This whole thing is a perfect square, and this whole thing is a perfect square. So I would square root that first one. The square root of x squared plus 8 squared is x squared plus 8. And the difference of 2 squares, we would repeat that, putting it in first in each parentheses. And then I would square root 36x squared, and I'd get 6x. One gets a plus and one gets a minus. And then in each of those parentheses, I actually think this was like the example we did yesterday, right? Each of those parentheses are out of order. So I'm going to rewrite them in decreasing degree order. And each of them is a trinomial. They're not perfect squares, right? But the last term, I want to see if there are factors of 8 that sum to 6. So this would be 2 and 4, and I get x plus 2 and x plus 4. And then factors of positive 8 that add to negative 6 would be negative 2 and negative 4. So I get x minus 2 and x minus 4. And that whole thing would be my solution, or my factored form. Michael?
You have to put parentheses between the x plus 2, x plus 4, and the x minus 2, x minus 4.
Like another set of parentheses, you mean?
Yeah.
No. I don't know if I'd mark it wrong if you did, but you don't need to. Rodrigo.
My question is number 2, and it goes 1,296 u to the 4th minus 1.
That's fun. All right, so 1,900, because 1 is a perfect square, u to the 4th is a perfect square, and there's a minus between, I would see if I could break down that square root of 1,296. So I know 2 goes into it, it'd be 648, and then 2 again, it'd be 324, and then 2 again, 162, 2, 81, 9, well, let me do 3. It's just going to get there eventually anyways. 3 and 27, 3 and 9, 3 and 3. So then, because it's a square root for each pair of a like number, that's 1, 2, it would go to the outside. That's a second 2, go to the outside, a pair of 3s, and another pair of 3s. So this is 4 times 9 or 36. So while that's a big, perfect square, you can break it down. They won't be that big on your quiz, okay? But you could always break it down if you didn't know what it was. So that means that it's square rooted is 36. So then I would do 36u squared, because that would be the square root of u to the 4th. 36u squared, and 1 gets a plus 1, and 1 gets a minus 1. Now, the first one is done because that's the sum of 2 perfect squares, but the second one is, again, the difference of 2 squares, and that can get broken down further. So the first one stays, the second one becomes 6u plus 1 and 6u minus 1. Good. Other questions from the homework? All right. Okay, quiz on P4 is all the factoring. It's 14 questions. It is all open-ended. There will be no calculators, no reference sheet. This cannot all be divided by the same thing, okay? They're not perfect squares, so I'm going to do first times last. You could also do trial and error, but negative 27 times 2 is negative 54. Factors of negative 54 that sum to negative 3 would be negative 9 and positive 6. Replace the middle term with that, negative 9x, positive 6x, minus 27, and then factor by grouping. So from the first one, you can take out an x, and you'd get 2x minus 9. The second one, you could take out a 3, and I'd get 2x minus 9. The 2x minus 9s repeat. And then x plus 3 gets grouped together. Oh. Right, 7 goes into it. 343, 7, 4. 63, 9. Yeah. So this, again, I wouldn't expect you to know that off the top of your head, but 343 is 7 cubed, okay? And then 125 is 5 cubed. So this is the difference of, so the sum of perfect cubes. It would be 5t as the cube root of 125t to the third, and 7 as the cube root of 343. So the first set of parentheses is just those two. Then we square the 5t, so it'd be 25t squared. We multiply them together, which would be 35t. And we square the 7, so it's 49. And then same, opposite, always positive. So they won't be that big. Like 343 is not going to be. Like I would say as long as you know up to 5 cubed, you should be okay. I will say this, overall, not horrible. Lots of you are doing great, which is amazing. And then some of you are like really struggling, and I don't know what you're waiting for. There will be no magic fairy dust that sprinkles over your brain to help you teach all of the things of factoring. So you either need to figure out where it is you're lacking, and if it's overall, that is literally 4 days worth of videos, okay? You have to stay on top of it. So this first one was 2 terms. You can't factor anything out. There's a minus between them. They're both perfect squares. The way we test the exponents is if they're even. So this is the difference of 2 squares. I'm going to square root the first term. That would be a 9s squared. And then I'm going to square root the second term, and that would be a 4t to the fourth, because we divide the exponent by 2. One gets a plus and one gets a minus. Now that first one is a dead end. You cannot, there's no such thing as the sum of 2 perfect squares. So it's done. That one's going to stay. But the second one is the difference of 2 squares. Again, God bless you. Square root that 9s squared and I get 3s. That's going to happen twice. Square root the 4t to the fourth, and that's 2t squared, and that's going to happen twice. One gets a plus and one gets a minus. And that's as far as it goes. You have to go until you can't go any further, though. So if you left like the first one, you're going to lose some credit on those questions. Don't do that. First one, not so bad. This was you can't take anything out. They are not perfect squares. There's a term at the front. So we're going to do first times last here. So 2 times 3 equals 6. Factors of 6 that sum to 5 are 2 and 3. I'd get 2x squared plus 2x plus 3x plus 3. And then I'm going to factor by grouping. Take out a 2x here, I get x plus 1. Take out a positive 3 here, I get x plus 1. And then x plus 1 is what repeats. And 2x plus 3 gets grouped together. You could have also done trial and error on that one. It wouldn't have been that bad because they were both prime. And most of you got that one right. The second one is where it went south here, okay? These are both perfect cubes. Anything raised to the third power is a perfect cube, and then 27 is a perfect cube. So this is a perfect cube, or the difference of a perfect cube. So we cube root each term. The cube root of b plus 3 to the third is b plus 3. The cube root of 27 is 3. In the first parentheses, we just list them. We're going to come back and fill in the signs, but I put them both. The second set of parentheses, we square the first term. We multiply the 2 together, So 3 times b plus 3. And we square the second term, which would be 3 squared. Then our SOAP, right? Same matches this sign. Opposite, always positive.
So what do you do for the middle term?
You multiply them together. Multiply the cube roots.
Okay.
So square the first one, multiply the two together, square the second one. Now, I don't even know what to do at this point because I've said it so many times, but b plus 3 squared does not equal b squared plus 9. It's still happening, folks. That is not, you cannot distribute an exponent on a sum or difference. You have to expand and FOIL that. So I can either do b plus 3 times b plus 3 and expand and FOIL, or I can use my shortcut, which would be b squared, double the product, so 6b, and then 3 squared, or 9. If you don't remember the shortcut, FOIL it out, but for the love of God, stop distributing the exponent, okay? You cannot distribute the exponent to a sum or difference. So my first set of parentheses, the negative 3 and the positive 3 actually cancel, and I have just b on the front. The second set of parentheses, b plus 3 squared is what we just did, b squared plus 6b plus 9. The middle one, we're going to distribute a positive 3, so plus 3b plus 9 plus 3 squared, which is 9. Yes.
How did you do the b plus 3 to the
I expand, well, I said you could do it two ways. You can either expand and FOIL it, so first, outer, inner, last, or you could do the shortcut, which is square the first, square the last, double the product, and put it in the middle. From here, we're going to combine like terms. There's only 1 squared. There's a 6b and a 3b, so that's 9b. And then there are 3 9s, which would be 27. So some of you got all the way there. Fantastic job. But a lot of you made mistakes along the way on that one, so please make sure you're careful. Okay, this one, you overall pretty good. The top one, you have to factor by, there's nothing to take out of all 4. There are 4 terms, so we're going to factor by grouping. From the first set, I can take out just a u, and I get u minus 3v. From the second one, watch your signs because there were some mistakes here. I could take out a negative 6w, and it would be u minus 3v. Then the u minus 3v repeats. That's my greatest common factor. And the 6 minus u, u minus 6w would get put into the second parentheses. The one on the bottom, I can't take anything out of all 3, okay? The first one's a perfect square, but the last one is not. So I have to do either first times last or trial and error. If I multiply first times last, 9 times a negative 6. Okay, it would be 9 times negative 6. Sorry, is this glitching? Okay, on the 9m squared minus 25mn minus 6, we're going to multiply first times last, so I get 9 times negative 6, and I get negative 54. Factors of negative 54 that sum to negative 25 are negative 27 and positive 2. I replace the middle term with those, making sure that the m and the n. And then factor by grouping. So from the first set, you can take out a 9m, and you'd get m minus 3n. From the second set, you can take out a 2n, and you get m minus 3n. And then it's m minus 3n times 9m plus 2n. Okay, so again, on the first one, we rearranged it. We got x squared minus 23x plus 42. You're looking for the factors of positive 42 that sum to negative 23, which were negative 2 and negative 21. This also, like if you left it as 42 minus 23x plus x squared, then you would have gotten 2 minus x and 21 minus x. It's still totally right. On the second one there, this was a perfect square trinomial, okay? Again, first and last were perfect squares, so I did the test. Square root the first term, it's x. Square root the 49y squared, it's 7y. double that product, and you would have gotten 14xy. Ignored the sign when you're checking. So the 14xy matched the 14xy, which meant this was the perfect square. And then we square root this first term, and that's your x. You square root the 49y squared. That's 7y. Be careful, some of you lost the y. You take the sign from the middle term, and then you put it in the parentheses, and you square it. Some of you wrote it out as x minus 7y times x minus 7y. It's totally fine. It's still right. Just can't switch the signs. One's a plus and one's a minus.